Welcome, everybody. It's Mrs. Dunn. What I want to do in this screencast is talk about compound interest. Specifically, what you want to learn in this screencast is how to define compound interest, and we want to use the compound interest formula to solve some problems. So, compound interest is definitely something you're going to have to deal with at some point in your life. You're going to buy a car, you're going to buy a house. Maybe you've already done that. You have a savings account, you have school loans. So, it's important that you understand this concept of compound interest. I really enjoy this quote from Ben Franklin. It sort of explains why the rich keep getting richer. Money makes money, and the money that money makes more money. So let's dive in. First of all, let's look at the definition of compound interest. By definition, it is the interest that is computed on the principal and any accumulated interest. So let's look at a specific example. If Kelly invested $1,000 in a one-year certificate of deposit that pays 2% interest compounded quarterly, find the amount in the account after 1 year. Now, we can do this using a simple interest formula. It just takes a little while. So let's walk through this. So remember the simple interest formula is I equals PRT. So after the first quarter, we're taking the principal times the rate, written as a decimal, 0.02, times the length of time. Well, we're calculating this after the first quarter. Remember, 1/4 is 1/4 of the year. 1/4 of the year is 0.25. So, multiplying that all out, we get an interest of $5. So that interest is added to the amount that we invested, our principal, and our new principal is $1,005. Now we're going to go through this process again. But this time, we're calculating the interest using $1,005. And we get $5.03 in interest, which gets added to the principal, the previous principal, which was $1,005. And now we have $1,010.03. And then we're going to do it 2 more times. Now, can you imagine if I wanted you to calculate this for, this interest being compounded quarterly for 10 years? You'd have to do this 40 times. So there's got to be a better way. So notice this $1,000 grew to $1,026 over the 1 year period. Now, with simple interest, it would have only grown to $1,020. So you ended up earning 16 more cents in interest. Okay, too long. Takes too long to do that. We don't want to use the simple interest formula. There has to be a better way. And there is. That's the compound interest formula, which is written here. A is equal to P times 1 plus R divided by N to the NT power. So A is the amount that accumulates in the account. That's sometimes called the future value. This compound interest formula actually gives you the amount of the principal plus the interest. P is the principal, just like before. R is the annual rate written as a decimal, just like before. Now this is new. N is the number of compounding periods per year, and T is the time in years. So when we're talking about those values for N, if the interest is compounded monthly, that's going to be 12 times per year, and N would be equal to 12. If it's compounded quarterly, that would be 4 times a year, and N would be equal to 4. Semi-annually is 2 times, N would be equal to 2, and annually would be 1 time, where N would be equal to 1. Okay, let's dive in and look at an example. Suppose your long-lost rich aunt leaves you $10,000 in her will, and you being the smart, intelligent math student that you are, you decide to invest that money in an account that pays 5.25% interest compounded quarterly for 5 years. how much interest will accumulate. Now remember, if we were using the simple interest formula, that's going to take a while. Okay, we would have to do it 4 times a year for 5 years. We'd have to do 20 calculations. Nobody wants to do that. So we're going to use the formula. So first you want to identify all of the variables in this formula. A is what we're looking for. That's the amount that's going to accumulate our future value. The principal is $10,000. The interest rate is 0.0525. N is going to be equal to 4 because this is quarterly. And T is going to be equal to 5 because it's for 5 years. When you put that in the formula, it looks like this. Now let me show you how to do this on your calculator. So we're going to type in 10,000. And you can use parentheses on the graphing calculator, which is really nice. And we'll put 1 plus 0.0525 divided by 4. Now we're going to close this parenthesis and raise this to the 4 times 5 power. I really suggest you do that multiplication in your head so that you get the correct answers on your calculator. Those of you that are using an older calculator, for example, if you're using the TI-83, your screen probably doesn't look like this. It probably has a caret. That's this caret. Remember, that's how we got the exponent. And you would have to put 4 times 5 in parentheses. You can save the hassle by just typing 20 because I think you all can figure out 4 times 5 is 20. So anyway, the answer comes out to be $12,979 and roughly 58 cents. Okay, I feel like I skipped over that. I just want to show you when we're raising something to a power, you're using this caret button, like 6 to the 5th power. You're using the caret button to get 6 to the 5th. Okay. So the amount that is in the account was $12,979.58. But the question was, how much interest will accumulate? And the amount of interest is the difference between the amount that's in there now and what we started with. So we've accumulated $2,979.58, and that's the interest. Okay, so I want to expand on this, okay? What if the interest is going to be compounded monthly? So you would think if it's compounded monthly, well, whoa, it was 4 times a year before, now it's monthly, I'm going to be making oodles of cash. So let's put the formula, the numbers in the formula, and you'll notice that the accumulated amount was $12,994.32. Definitely more money, but not necessarily a lot more money, okay? What if it's compounded daily? We can put that in the formula as well. And we get the amount of $3,001.52. Let me put this in the calculator just to help you. So I'm investing the $10,000 and the interest rate is 0.0525, compounded daily, which is 360 times a year, raised to the 360 times 5. If you're typing this in your calculator, you can type 360 times 5 as long as you put it in parentheses. Those of you that have my calculator, it doesn't really matter. But if you have an older calculator, make sure you put that multiplication in your calculator in parentheses. So you'll see we get that amount of $13,001.52 roughly. Okay, I want to explore this a little bit. So if you look at these 3 examples we did, these were the amounts of money we earned. So when the interest was compounded monthly, we only earned about $20 more. And comparing monthly to daily, we've only earned another $7 roughly. So what exactly has the greatest impact on how much money you're going to make? So I'd like you to pause the screencast, practice using the compound interest formula, and find out how much money you would have in your account if you double the interest rate for the same amount of time, doubled the time with the same amount of interest, and doubled the money with the same amount of interest and the same amount of time. And this is all calculated quarterly. This is when your interest is compounded quarterly. So take a minute, pause the video, and get those answers. What do you think has the greatest impact on how much money you make? Doubling the interest rate doesn't increase how much you make as much as doubling the amount of time. Remember that. And obviously, having more money will result in having more money. That's the whole thing I started with the quote from Ben Franklin. The more money you have, the more money you're going to make. So definitely investing the most money is going to give you the most interest. Okay, that's it. Good luck, guys.